We are recording. Um, Welcome to the monthly Austin Python meetup. Uh, it's the end of the year meetup, and for the end of the year, we have a very special guest. You don't usually see lawyers who code come to the Python meetups. And this time, we were able to get two of them, and you will see what they are thinking about programming specifically with Python, but software in general. So the two lawyers that we have here are Robert McKee. He'll be speaking first, and he will be talking about patents and machine learning, and he's going to show you what he does with machine learning to understand for machines to understand patents. This is the best I can describe it. He will explain better. And later on, we will not be recording this, but DC Toedt was gracious enough to join us, and he will speak about copyright, software, all sorts of things related to software licenses that are very important for people to understand. If you're going to go and do programming for a long time, those things have long-term effects, and DC is going to speak about it much more than me and much better than what I even can imagine. So without much ado, Robert, please, the stage is yours. You can open up your presentation and show us how machine learning can help understand patents. And explain to people what patents are, because not everyone knows.
Sure, and you're able to see my patent analytics screen right now. Perfect. So I'm Robert McKee. I am still a licensed attorney, but I do data science now, and but I got into all this stuff because patents are a treasure trove of information, but there is so much of it. And so when I started learning that Python could help me filter through a lot of that patent information and that text, and I could turn text into data that was useful for me, then I just started doing a deep dive into it, and I kind of just never looked back. So this, what I want to talk about today is the different ways I've gone about patent analytics, and I called it There and Back Again, kind of, referring to Frodo, Lord of the Rings, because I have gone back at this problem multiple times, and it seems like every few years there's a much better way to do it. And the first time I did it, it was sloppy, it was slow, it was hard, and I maybe got 10,000 patent applications through web scraping. But now I'm able to use public data sets and SQL and filter through millions and millions of patent applications in a few minutes. So it's a hidden gem of free text and images and time series data that you can access and play with and discover insights from. And I encourage more people to look at it, because not many people go look at the patent data set, but it's massive and public and easily accessible. So, all right. My next slide, who I am. I'm Robert McKee, and I start off as a microbiologist working in a level 3 lab with a hood, the interesting hoods you see now in the news all the time. So that experience suddenly became very relevant this year, especially when wearing masks. But then I transitioned over to become a business and patent lawyer, where I kind of focused on patents with startups. And so how do you recognize a good idea? How do you protect that idea? And how do you build a business around it? And it was during that time that I started learning about Python and how I could use code to kind of make my day easier. But now what I do is I apply the call center AI from Google to make chatbots for telecom industry. And this all this data that I work on is text related, which is natural language programming, and it has a lot of different applications. The trick is finding a problem to solve. There's no shortage of data, but trying to figure out what problem to solve can be pretty challenging. So I got started learning Python by having projects to solve. And I highly recommend the book, Automate the Boring Stuff with Python. It will show you all the little things that you can automate during your day that normally are kind of manual and challenging. This talks about web scraping, automated form fills online, cleaning up, automated cleanup of Excel files, which I found very handy. And if you're learning Python or just starting out or trying to see how relevant Python is, or want to find ways to make your work go a little bit faster, then I highly recommend that book. So what is patent analytics? So patent analytics is really just going through patent applications. And patent applications are a type of legal document that protect a new invention. And they've been around for a long time. And one of the reasons that I've really enjoyed going through them is because they have a very formulaic and structured format that you have to follow. They have images, they have long form text, they have these strange claims that are written in a form that's designed to be confusing and not understood by anyone. But it's very important for businesses. I think, on average, a patent litigation case can cost upwards of $2 million each side. And the cheaper cases cost, $300,000 to $400,000. And to get a patent application can be anywhere between $5,000 to a couple $100,000 if you're trying to get a patent in multiple countries around the world. And when you think about that, it's, the numbers add up. And so it's important to know how you're spending your money and if it's worthwhile. So one of the things I want to stress is that the data set that I'm going to be kind of showing today, it's 1.9 terabytes it's on Google BigQuery, publicly available, and has 120 million records that go back to 1782. And the ones in 1782, I think, are in German. So there's multiple different languages, opportunities for training translation models. There's images and images that are described. So they have text that matches with those images where they describe them. So that also, there are different machine learning models that you can build that relate to that as well. But it's just a treasure trove of information that I think more people should look at. There are lots of different things you can do with it. One is patent landscaping. So what that is you're kind of looking at who's getting patents on what types of technologies, what areas your competitors are focused on, and that can give you insight as to what they think the future is going to be in certain areas of technology, or it might show you that there's a gaping hole in a technology sector that you could spend your time and money to get some patents on and kind of position yourself to be bought out by like a large mega corporation, or to just build some technology in a company that you're really passionate about. The other thing is that if you have a problem, you can look through this massive data set and find solutions that are on expired patents. So they're free for you to use, that they're just a little older. So and I'll show you some resources of where you can go to find different methods of patent analytics. But one of the areas that I focused on initially and as a lawyer was predicting patent outcomes. So what does that mean? That means, a client comes to me, says, I want a patent on this device. And so, I write it up, send it off to the patent office, and they tell me it fits into this type of technology, and then you go through a series of rejections and corrections and fees. And it's there's kind of the joke that once you pay enough fees, you've got a patent. And but when you're a startup, that's a lot of money that could be better used in other places, like marketing, or paying a software engineer, bringing somebody else on. So you want to know that you're not wasting your money on this. And one of the big problems is that half of your money that you spend on a patent is going to be spent writing it and then submitting it to the patent office. And so kind of the back and forth with the patent office, you're going to be spending the rest of the half of your money. So if you can kind of predict how the patent office is going to treat your application before it gets there, then you have a better idea of if you're spending your money wisely. Because once you send it off, you've just sunk half of your budget. If you get a bad ruling on it, or if it goes to one technology center and they have a higher rejection rate than another technology center. So I early on started looking at I kept hearing that software patents were not something you could get. So but I started seeing all these AI patents that were going through. So they're two different technology desks, and one has a much lower rejection rate than the other. So I wanted to use AI to see if I could look at terms to predict how an application was going to be described by the patent office. And it turns out, you can do a pretty good job of that. And so you can use that in writing an application. Also, after the fact, if you see what your patent application has been labeled as, you can decide if you want to go forward with that and, throw more money at it. So it's got a lot of uses. It's got a lot of time waste too, because it's such a large data set. But, if you like it, it's a lot of fun. So there are a lot of people working on this, and there are a lot of companies working on this. But some of the people that I found really interesting were these three, because they show examples of their code. Like Google Global Patents, they have a GitHub page with code on how to do a lot of this stuff. And they publish stuff regularly, and they're really interested in it. Also, they host BigQuery and the public patent data set. And if you can search patents.google.com to look at patents. So they have a lot of expertise in that area. Also, the Berkeley Fung School, the engineering school, it's very unique in that they've got quite a few posted case studies where people did data science and machine learning on patent applications. And a newer one is this department at Carnegie Mellon that started up dedicated to patent analytics. And so I think they're going to be really interesting to watch over the years as they kind of, develop research and projects. And it'll be another source for you to go to learn about NLP and just kind of big data analytics in general, because again, this is a huge data set that's accessible and not behind a firewall, paywall or a firewall. So now I'm going to get into kind of the more programmatic parts of patent analytics. And this is the kind of the steps that have taken place over that you go through each time, and what I did the first time and then the second time. So the first time I used web scraping and for data collection, which involves going to these websites programmatically, pulling the content off, and then organizing it in different ways. I used Excel, and don't hate on Excel. Pivot tables are powerful. Like, you can do so much with that you can spend a long time doing machine learning, but Excel can oftentimes just give you the answer you want. And then, there I just used basic Excel charts, and it wasn't anything fancy, but I was really proud of it. But now the process that I go through is I use SQL. So I go to BigQuery, I access their public data set, and with SQL I can go through millions of patent applications and pull that data out in minutes, whereas the web scraping could take me weeks. For one, programming it, and also being a nice web scraper, so not doing 100 requests a second, instead waiting a few seconds between calls. For data analysis, I use a lot of different libraries, but primarily pandas, and it's kind of a beefed up version of Excel. And I'm going to show you some other tools that I use for the data analysis portion that have come out recently that are that make the exploratory data analysis process pretty fast and more visually appealing. And for presenting your data, if it's just sitting on your computer, then it's not always as useful. But I'm going to show you how you can deploy it with Streamlit, which is something newer, and I really like it, and it makes it really easy. You don't have to worry about HTML or other UI elements. You can just kind of host your code on GitHub and then use Streamlit to deploy it. And again, all this stuff will be available to you. If you actually, in the questions link down there, it might give you the link to the slide showing where all this stuff is. But so right now I'm using Colab, and there's a section where you can learn more about that. But also for running Python files on your computer, in case anybody doesn't know how to do that, I want this to be accessible for everybody. So we're going to go through the data collection portion. And I'm not going to go in too much depth with this. I'm giving you enough to get your interest into it, so then you can go back later and go through this stuff. But the code I have right here is using a mechanical suit, which is kind of an offshoot of using Beautiful Suit. But it is a lightweight version that allows me to go to a website programmatically, like here's my website. It's got this text on it and images, that type of thing. And with Mechanical Suit, I do this right here, and it turns the website into this HTML code and CSS so that I can just see the text version. And this is messy and chopped, and you need to chop that up to pull information off. But Mechanical Suit makes that really easy. So to get all the links from the page, I just do browser.links. And now I have all the links, and I can go through those. To get the text from the paragraphs, I just do find all P for the HTML tag, and it gives me the text from those as well. So this is what I had to go through early on to collect patent data, because I didn't have access. I didn't know about a bulk download version, and the information I wanted was spread out among different places. So that was the old way. Now, the new way, in which I highly encourage you, is Google BigQuery and using SQL with that. So in the middle here is just a SQL query that I wrote, and it's going through 1.9 terabytes of data, collecting some names of some companies who have the patents, if they're a large entity or not, and filing dates. And then I can just download that to my computer for later use. So Python is great, and this meetup is about Python, but SQL is a great way to gather information, and I encourage you to learn it. So now with all that information, I'm going to import that file, which you'll also have access to when you're running this, into Pandas in this notebook. And it turns it into what looks like an Excel file, a typical Excel sheet that you normally use. except it can handle a lot more rows. So I think Excel will max out at about 150,000 rows. This, I think, you'll be using for a few million, but then past that, you'd be using some different tools to just make it faster. So you've got all this, everything, all your data into a format on your computer, but you need to go through it. So these are some of the libraries that I've come across recently, like dataprep.eda. So they kind of just instantly show you information. So as far as like patent analytics go, if you're looking at this screen right here, you're going to see IBM come up. It has 28, and I was just doing the most recent 500 applications. They have 28 out of the recent 500. IBM has been the most dominant patent submitter and patenter for the past 20, 25, or 30 years. And so, their name's going to come up a lot.
They also litigate, or they just submit patents a lot?
They license, so I think they do litigate. I think what I was told was that their patent kind of just army spawned from the 80s of doing a lot of litigation. And once that ended, they had this massive in-house law firm, and they needed something for them to do. So they started pumping out patents. But DC, if you have any other information on that, please chime in.
Yeah, Robert, there's a question. Tom is asking if there's a repository for this. I think if you publish somewhere.
Yeah, and it's I'll show you. It's at the very end, or
okay.
If you go to the Ask Questions at slides.app.google, I think you'll have access to the slide where it shows the link. But I can also post it in the chat right once I'm done.
And there is asking if you use BERT. I'm not sure.
BERT. Yes. So BERT, and then more recently, I think it was CPT2. I was playing with, or GPT2, and it was interesting because I put in some initial claim text, patent text, and it did generate some pretty good patent application language. So I, assumed that model was trained on patents, but it's definitely something to look at, and it's pretty fun. And so, dataprep.eda is a good one, and you'll be able to go through all of this stuff too. But this is going to make your life easier for visualizing everything, because you need to, make charts, see how these things relate to each other, and these tools are a lot nicer and make your job easier, and are very important in the early stages of patent analytics.
Which tools are you using for visualization? I'm curious, because there are so many tools out there.
There are so many. So this dataprep.eda one is, it's interactive. It shows. It was a later version of, I'm not sure if you've heard of, it's like data profile, maybe data profiler, but this one is faster, and you can control which portions you have it process so that it's not processor heavy or crash your notebook. But Matplotlib, you're going to see other visualization tools like Matplotlib, Bokeh, and Plotly, and those are really great for doing more customized visualizations. But this kind of exploratory data analysis, just throwing in the files, is really helpful just to get started. If anything, just do it for the missing data. Because this chart right here, shows that there's no missing data in the different columns that I have, because it's important to know if you've got some a column that has a lot of missing data, and how you're going to handle that. And if you've got millions of rows, you're going to have to figure out a way to get through all those, and you're not going to scroll. So all of these tools are in there. I'm just trying to give you kind of a big overview of all this stuff. And one of the things that's not shown as much in data science projects is deploying it. And you come up with this model, and in my GitHub I've created a machine learning model that classifies patent applications, but it's just sitting there on my computer. Nobody can use it. And so the different ways that you can do it is you can create an API with like Flask. You can also deploy an application with Flask and Heroku. But more recently, and you have to request an invite, but they're really quick on responding, is Streamlit and Streamlit Share. And so what you do for that is, I've got some instructions right here walking you through the process, but you basically just put your code on GitHub, which is a good practice anyway, and then connect it up with Streamlit, and then you've got an application. It's almost as easy as that if it loads. So this is the patent application that I built. I built the model. The Streamlit geniuses did all of this pretty version stuff. And so I've got some patent text in here, and pretty sure I clicked it. Yeah, it's running. And then it will process it on the model and present the results. And so, I wanted to kind of give you an end-to-end overview of this process. The web scraping, which it's useful for in a lot of things. If you're in an industry and each day you want to see different blogs or something else, you can create your custom kind of aggregate news, and you can kind of automate tasks. It's extremely useful for Python. A Python tool is extremely useful.
So how does the Streamlit know how to use your model? Do they ask you to set up your code in a particular way, or you have to have an entry point, right? You have to have some kind of a predict function,
yes,
or something like that, right?
Yes. So let's go over to my, while that's running. So this is the app. I've saved the TF-IDF, which is a vectorized version of the text. I've saved that. Also, I've saved the train model, the train machine learning model. And there's code here for explaining how to do that. But this is the code for the app, which isn't that long. So I'm importing Streamlit, NumPy, Pickle, Pandas, Lime. I'm loading the trained files, or the trained models. And then this is all of the kind of visual portion of the app. Okay. And this is and so, yeah, I tell Streamlit that this is the GitHub repository for the app and the model. And then it's got some API that you can follow for how you want people to use that. And this is the output. So it told me that this is 706, a high probability of being 706. And there's a big emphasis also on explainability of your model in data science. And visualizing it with the original document, I found, is extremely useful for a lot of people, especially lawyers, because the confusion matrix is just confusing. But the line visualization shows you the important words that it was using to determine if it was more in this class or more in that class. And so as you're reading it, you can kind of go through and see, okay, it's these certain words. And the reason I knew that it was actually really useful was the first time I got it working, I showed some people that didn't know anything about machine learning. And they were like, well, your model's highlighting the word "the." why is it doing that? It can't be that great. I was like, that's not important. What's important is I got it highlighted and it's presented in a useful way. So it's great for showing people how your model's working so they have more trust in what your model's doing. And with that, I'll, if you've got more questions, I'm happy.
Yeah. Please stop. So we're seeing the prediction probabilities here. We see 3 colors, 3 bars. What does it actually tell us? Like, please go through. So explain the colors and explain what we're seeing on the plots and explain what we're seeing.
Sure. So, and right now it's just showing you between, not 706 and 706. But
what are these?
It's so 706, 705, and 700 are 3 different, basically kind of examination units at the patent office. So 706 is going to be more, and it's like AI, big data type of thing. And then 705 is going to be, in 700 are like more what you call software, I guess. They're like business method patents. And if I have those backwards, then I apologize. But what it's saying is that it's looking at this, a lot of terms. So the TF-IDF model that I mentioned earlier, what that's doing is it's showing, it's pulling from the few thousand patent applications I had, all the words, and finding out kind of which words are most likely to relate to which type of patent. And by doing that, and what I wanted to do with this was you can then see what words you should be using to get it into one class or the other. And what I found earlier was that, the rejection rate of the different classes there's a huge difference. So like it was 705 that had a 32% rejection rate, whereas 706 had a 3% rejection rate. So, it was fairly obvious that, one group did have more rejections. And so it's a different group of examiners looking at those patent applications in a different way. And so my goal was to write applications in a way that has the best outcome legally for my clients and staying ethics bounds, but, write something that encapsulates their idea. Write something that protects their idea, but gives them a better chance of succeeding. So, sorry, I guess I'm losing my voice, but, and so the whole model is trying to find different words that will predict which class it is. And so this, yeah. Sorry, go for it.
So yeah, there's a question if you had any data on the rejections on 101 and 103 grounds.
Yes. So there, and I actually used that, and it's in a different GitHub repository that I have, but I was able to get the, from the patent office, they had a file that was, that explained the rejections for each application. So then I could match those two up. But now when I was looking back at the BigQuery dataset, I think they've added those explanations into the public patent dataset. So, I did it the hard way, but you can find all that information there and merge them.
Any more questions? Please ask. I have a question while everyone thinks about the one. You've used a lot of visualization libraries. You mentioned Matplotlib, Bokeh, Plotly.
Yeah.
You use the interactive options of those. Like Plotly has some interactive, Bokeh has some interactive.
Yeah. And that also is another question. You know, I really like Plotly. It was, that one was kind of easier to use, but again, like all of these things, they're changing regularly, and there's new ones coming out, you know, almost weekly now. So a great place to find information on that stuff is on Medium. I found it, but I like Plotly and Dash. Those can create interactive dashboards. But it comes down to, you know, what works on the platform or tool that you're using at the time and what you like best. Because I think one of the reasons I like Plotly a lot more now and suggest it is because I've been using it more. So I could help somebody with it who I've recommended it to when they have a problem. But there's no right or wrong answer there, but there's a ton of them. And I'm sure there will be 10 more next year.
Oh, we actually have some of them lined up for the presentation for next year and from previous years in the Python meetup here. There's some videos
Nice.
about them. Check it out.
They're all great. And yeah, they do some cool stuff.
More questions?
Yeah, I have a question. It seems like patents, the drawings are very important. Are you aware of any work at like object detection or analysis, using deep learning?
You know, not specifically. I tried, one of the things that I did over a Christmas holiday one time was use Amazon EC2 instance and try to do transfer learning to draw patent images from sketches and refine them so that they would meet the requirements. But the thing about patents is that they're boring to most people. So they ignore this treasure trove of data. And Google's doing a lot of that. Google Global Patents Group is doing a lot of work like parsing these patents. So you can go on there in their public data set and find the images, find the text for them that describes them, and do deep learning on those. And I highly encourage you to. It's really accessible, especially with SQL.
Okay, thanks.
Any more questions? Or Florin, are there any more questions in the chat?
I think there are questions. I think more like comments. Let's see, the KNN text classification algorithm based on, it's more of a comment.
Yeah.
Oh, do you have comments? Yeah, I'm not sure I understand that question.
Who asked it? Maybe they can ask.
They did, yeah. I'm not sure if it's a question or is it a comment.
KNN based on feature weighting is proposed. No, I'd have to, I guess, read that more in depth. But yeah, and so all of the web scraping and patent analytics and kind of visualization code is there for you to use and kind of get your feet wet so that you can get in more trouble.
So this is your GitHub, the one that you're presenting now?
Yes.
Okay, so this is where we get your presentation and you can see all this.
Yeah. And I put it in the chat, and then just when you get here, just click open in Colab, and it'll open up, and you can start playing around with a copy of it.
Okay. And the website that you just showed us how it analyzes patents, is it available for everyone?
Yes, and I think that might be also on there, but I'll share that with you as well.
Yes.
There's a lot on GitHub. There's a lot of repositories that are showing Streamlit apps as well, so you can find a lot of examples on how to build something.
So is a Colab? What's Colab? Is something that Google offers? Or what is it?
Yeah. So Google Colab is it's a way of running Python code and some other code with basically a Google Cloud backend. Amazon has SageMaker, which has EC2 instances connected to that. But with
more like IPython or Jupyter notebook.
Yes. It's a Jupyter notebook with Google Colab backend, and so you can share it with other people. They can work on it, and if you have Google Drive, you have access to it. And if you need a GPU, you can just go in there, change the runtime type, and pick GPU or TPU.
Cool.
So it makes machine learning really accessible for everybody.
Yeah, that's very convenient.
Okay. So unless there's really some pressing questions that someone come up with by the time I finish asking you all to clap your hands or virtually clap your hands to thank Robert, you can ask them. You can stick around at the end. If Robert is going to stick around for the entire talk, then you might have more questions. But at this point, if it's all okay, I'm going to stop the recording, and DC Toedt is going to speak more about licenses. So I'm stopping the recording now.